3.
Hi, my name is Lam Sen Long and my metric number is F2481120.
Hi, my name is Nur Amira Akila binti Muhammad Zahir. My metric number is F24B1015.
Assalamualaikum and good afternoon, guys. So my name is Muhammad F-F2073 and my metric number is F24A1356.
3.
Hi, my name is Nur Arishana Jo binti Muhammad Syukur. My metric number is F2481280.
So we are from group 60. The group name is group 16. So today we going to explain the project 20% statistic. So first.
So this is our working solution.
Today we will present our project 20% analysis for dataset A as part of our basic statistics course. In this presentation, we will explain the background of the project, the dataset used, and the objective of our analysis. This project is about analysis dataset A, which contains information from 200 patients. The dataset provides a relatively large sample size, which allows us to carry out statistical analysis and obtain reliable results. Each patient is assigned a diet type, which can be A, B, or C. In addition, each patient also has a disease-resistant status, which is classified as either resistant or non-resistant. These two variables are categorical variables, making them suitable for analysis using a contingency table. The purpose of this project is to explore whether different diet types are related to disease resistance. In other words, we want to examine whether the type of diet followed by a patient may influence their resistance to disease. We have two objectives for this analysis. Objective 1 is to summarize the relationships between diet type and disease resistance using a contingency table. This helps us clearly present the distribution of patients across different diet types and resistance categories. Objective 2 is to determine whether diet type is significantly associated with disease resistance using the High-stress test. The statistical test allows us to assess whether any observed differences are statistically significant or simply due to random variation. Now I will pass to the next presenter to explain our research question and hypothesis in more detail.
Now I will explain the research question, hypothesis, and the statistical test used in this study. So the research question for this project is there a significant association between diet type and disease resistance among 200 patients? Based on this research question, we formulate two hypotheses. The first hypothesis, the null hypothesis, states the diet type and disease resistance are independent, meaning that the diet type does not affect disease resistance. The second hypothesis is the alternative hypothesis states that diet type and disease resistance are associated, meaning that different diet types may affect disease resistance. So, to test this hypothesis, we use the chi-square test of independence. This test is appropriate because both variables diet type and disease resistance are categorical variables. The chi-square test helps us determine whether there is a relationship between the two variables. Next, I will pass the presentation to the next presenter, who will explain the estimation and the statistical result.
This diagram shows how the aspect equally is calculated for a chi-square test. So the first formula aspect equally. So E row total x column total equally grand total. So so the next is diet resistant. So 69 x 146 equally 200. So the total is 10074 equally 200. So the total is 50.37. So next aspect roll and column 200. So resistor and no resistor. So A 50.37, no resistor 18.3. So B 48.18. So 17.82. So C 47.45, and finally is 17.55. So I pass to next person.
So next is the decision rule and the test conclusion. So to make a statistical decision, we use the p-value and compare it to our significance level, which is typically set at 0.05. So if the p-value is less than 0.05, we reject the null hypothesis. But if the p-value is greater than 0.05, we fail to reject the null hypothesis. So the null hypothesis for our x-squared test was that there is no association between the type of diet and disease resistance. Since we fail to reject, we conclude that there is no significant association between diet type A, B, C and disease resistance. This is supported by our low chi-square test statistic that x-squared is 0.2133 with 2, which confirms that the observed differences in the data are simply due to the random chance and not a real effect. Now let's interpret what is statistical conclusion. This means that diet type and disease resistance are not significantly associated. In other words, the type of diet a patient is on does not appear to influence whether that patient is resistant or non-resistant to the disease. This concludes our presentation on the square test for independence. We have established that based on our data, there is no